Right, morning, we completed our discussion about why the lemon appear bigger when we observe in a glass of water, right? So here, simply, if we drop a lemon into the water, the person is able to see bigger in size. So suppose if I drop that into a empty glass, we can see something size of the lemon. So just you need to understand that size, how much it is. Blindly, we can estimate the size. Then what to do? Just fill that glass with water. You can feel that simply here, it is becoming larger in size. So why it has happened actually, right? So that reason we will know by the ray diagram, right? By the ray diagram. So what happened actually? Here, whatever it may be, you are viewing means something light you are receiving from the object. So without receiving the light, it is impossible to see that. So how it will be? That will be explained by a simply ray diagram. Look at this ray diagram here. So actually, original lemon is in this size, right? This light will be reached to you if it is empty like this, right? Here, what happens when we filled that with a glass of water simply, right? So here it is immersed into the water. Then here, your eye cannot perceive that refraction. I directly cannot perceive that refraction. Simply what it can estimate that what you are receiving the light, it is actually coming from the object, right? Here, suppose I'll show you like this. The direction of our light coming from the lemon is like this if there is no refraction from the top and the bottom. So with the edge along that straight. But here when water is added, your eye cannot perceive that refraction. What it can estimate actually, the light is estimated as coming from the image, right? Here, what actually happened at the interface where the light is leaving the water surface, at this place, the light will be refracted. Actually, the light is coming in this direction, right? At this place, the light is refracted like this, but your eye cannot perceive that. It can estimate the light is coming from this point. Here, actually, your eye is estimating, right? So what you are viewing actually, original light rays? No, refracted light rays. So here your eye can view that point of the object at this spot and bottom is at this spot. So your eye can realize that lemon is in this size. Is it actually in this size? Speak out. Is it actually in this size? No. It is due to what? Refraction of light, and your eye is not feeling that refraction, not perceive that refraction, not realizing. Due to this reason, you are viewing that lemon is in big size, enlarged image. So it is image actually you are viewing, not the original lemon, not the original lemon. So is it clear, everyone? Go to quick reaction. So this is given in the page number 60. It is given in the page number 60, right? So this is actually. Then the next topic for us, it is about image formation and derivation of a curved surface formula. So here, image formation. When it is possible to explain that formation of image by the diagram, here, if minimum 2 rays are considered, minimum how many rays required? 2 rays. That 2 rays must be either converge or diverge. So without these, we cannot get the image, or we cannot explain the formation of image, right? Compulsory, we require converging point of light rays or diverging point of light rays after refraction. Here, because you are discussing the phenomena is refraction. So here we need compulsory converging or diverging point. So then only you are able to explain the formation of image. So for that situation, I am considering one curved surface, right? We know curved surface. Here, whatever it may be, concave surface or convex surface, but by the refraction, how the image will be obtained. That is our topic. So here, I am showing you that mediums. So shaded region always dense or medium. Then another medium is a rarer medium. Here, I am representing the refractive indices of the respective mediums. We don't know. I am taking the rarer medium refractive index size N1 and the denser medium refractive index size something N2, right? N1 is the refractive index of rarer medium, N2 is the refractive index of denser medium, first medium, second medium. Then how I decided first medium, second medium? Because I'm placing the object in the air, object always in the air, then observing its refraction through the curved surface into the denser medium. Then where will be its image that we are estimating. So for that, I required a terminology that is pole and center of curvature P and C, right? So I got the points. Then connecting them called principal axis here, right? So here what we need, object. So here I'm going to consider certain object with a size called point size, right? Here the object is placed, point size object, right? Point size object on the principal axis placed at a certain distance from the pole. Here to obtain image of this point O, right? Object is placed point size object at a certain point O. Here I want to see the image of this point in the diagram. So whatever it may be, I required two rays from the point same, that is object, same point, right? Here I consider two rays, right? So one is along the principal axis, right? So which remains undeviated as we discussed previously. So here along the normal remains undeviate. Along the normal remains undeviate. So here it is the first ray. So I got the first ray behavior remains undeviate, right? Remains undeviate. Then here I'm considering the second ray. I'm considering the second ray. That second ray is going to meet at a certain point on the curvature, right? Can anybody know the behavior of this second ray? How it behaves after refraction? Can you predict what we required to predict that refracted light ray? Do I need anything?
Normal.
Very good. Normal. So how do I get normal, or how to draw the normal here? How you draw the normal? Simply connecting point of incidence and point C. That is what center of curvature. So here I am taking a certain angle for the incident ray. So what is that angle? Something unknown. So I am giving that angle as something alpha. So here, by making certain angle alpha, that second light ray incident on the curved surface at a certain point, right? This is second ray for us. So where it meets the curvature, that point I am taking as something A, right? At a point. Then here, simply I can draw a normal. A normal is drawn. So what will be the angle of incidence here? How do you measure, or where do you measure? Between normal and the incident light ray. So that angle I am taking as something unknown value, theta 1. So theta 1 is simply angle of incidence is taken as theta 1. Angle of incidence is given. Then, can anybody predict the behavior of light ray after refraction at point A? Anybody? We discussed in the morning class. Behavior of light ray, we are able to predict depending on the rarer medium, denser medium, and depending on the direction of propagation. So direction of propagation is rarer to the denser medium. If any light ray propagates from rarer to the denser medium, irrespective to its surface, it deviates from its path and it bends towards the normal. So light ray after refraction bends towards the normal. Is it clear, everyone? Go to quick reaction. How I trace that refracted light ray? Yes. So now, here I'm going to consider certain angle of refraction. Unknown, I am not measuring, but unknown value I am taking. That is something here, theta 2. So the point here I am representing where that light ray meets the principal axis, there I'll get the image, because here I got converging point of these refracted light rays. So this is first refracted ray, this is second refracted ray. They together coincide here at this point. So this point will give you image of point O. So object O image will be obtained at this point, right? So here now, what we will take this point as something I. So I is the point of image for the point O after refraction. So here do you got idea how to explain the formation of image here? By the help of two rays from the object from same point especially, then after refraction where they will coincide appear to diverge. That anything you need to find out, converging point or diverging point. So I got here directly converging point. So that converging point will give you the image. So I got the image at I. Then here I am taking the angle of refraction here for the refracted light ray between normal and the refracted ray, that I am taking as something theta 2. Okay. Then what the angle made by the normal with the principal axis, I am taking as something unknown value beta. Then refracted light ray making certain angle with the principal axis, that I am taking as unknown value something gamma. Right? What are alpha, beta, gamma? Alpha is the angle made by the incident light ray with the principal axis. Beta is the angle made by the normal with the principal axis. And gamma is the angle made by the refracted light ray with the principal axis. Right? Then here from point A, I am taking a vertical line onto the principal axis. It is vertical to the principal axis. The line, green color line, drawn from the point A onto the principal axis, that is perpendicular to the principal axis. So normal drawn onto the principal axis from the point A. So here that point I am representing something N. So AN is perpendicular to the principal axis. AN is perpendicular to the principal axis. That means at point N. Right. Now I am taking the distances between O and P. So any distance measured from the pole to the object, that distance is called as object distance. We are representing in a first lesson or in the fourth lesson, representing the object distance by U. So the distance between pole and the object is object distance represented by U. Then I'm measuring the distance between pole and the center of curvature. The distance between pole and center of curvature is always measured as radius of curvature, denoted by capital R here. Then I'm measuring the distance between the pole and the image. This distance is denoted by the letter V. So U is object distance, V is image distance, R is radius of curvature. Any confusion in this? Anybody? If you are clear, just give me your quick reaction. Okay, so maybe you understood the figure given in your textbook, page number 60 and figure number 5. So this is the meaning of the diagram. Blindly, I am not drawn. It is meaningful diagram. Have you understood the meaning? Have you understood the meaning? Any response? If you struck it at any point, just ask me. If nothing, we'll go for next. So is clear, right? So diagram is meaningful, right? Next. Here, we are using this information. So I will minimize this one. Okay, I got the diagram on the screen now. Minimize the diagram. Then let us go for the remaining discussion. Here, what you already represented here, what is U or V? Anybody? What is U? What is V? What is R? Anyone from you? What is U?
Object distance.
So U is object distance that is measured between P and O. What is R? What is R?
Radius of curvature.
Where do you measure that?
Between pole and center of curvature.
Very good. Between pole and center of curvature, we will measure the distance called radius of curvature. One more measurement is there, parameter. V.
Image distance.
Where do you measure?
Between pole and image point.
Right. So here, pole and image point I, P and I distance is called as image distance measured as V. So we got the parameters. Then now I'm finding the triangles with exterior angle. Can anybody find the triangle in the diagram with exterior angles? Triangle with exterior angle. Any triangle. So how many triangles are there? Nearly 5 triangles are there. 5, more than 5. In that, I want exterior angles. Did you see the triangles? So I will give you large image. Okay, here you can see. Now you can see that. Exterior angle. What is exterior actually? If there is a triangle like this, right? At any vertices, if you extend any side, it will give you a certain angle. This angle is called as exterior. How many exteriors are possible? 3 possible. Right? So find out exterior angles. Is this theta1 is exterior angle? Because at the vertex A, we have that. For which triangle is that? For which triangle? Theta1 is exterior or not? It is an exterior angle because it is in the triangle. Look at that triangle here. I'm using different color from point A. So this point and to this one, then here it is, this one. So look at that red color triangle. Here, if I extend this, the angle is made between these two sides, AO and AC. Right? So this angle is what here? Exterior. Like that, find out one more exterior angle. One more exterior angle is there. Did you see that? that is here angle beta. For which triangle is triangle A C I. Here it is, if I extend IC or CI like this, the angle made with the extended side and the side AC. Is it clear how to find out angles? Right. So I got exterior angles in this case. Right. So I'm clearing this. Right. I got a smaller image here for the diagram. Okay. Now here I got exterior angles from the given figure. Then let us see here. I want to establish the relation. Right? I want to establish the relation. What I mentioned here, above mentioned quantities. Right? So for this, I'm depending on the angles, right? And depending especially on the triangles with exterior angles. So for which triangles we got exterior angles? Theta 1 is exterior, right? That is located in the triangle ACO. Triangle ACO, right? So theta 1 equal to what we can write? Sum of the two interior angles. Sum of the two interior angles. So interior angles are there here. One is alpha and the other is beta here. So that's why I written here theta 1 is equals to alpha plus beta. Is there any confusion in this? How I written? Is it clear? Exterior angle is equals to exterior of a triangle is equal to sum of the two opposite interiors. Right? So by that mathematical knowledge, we are writing theta 1 equal to alpha plus beta. So here I have one more triangle with exterior angle, that is triangle ACI. Triangle ACI. So here in triangle ACI, I have exterior angle is beta. Exterior angle is beta, right? So exterior angle beta is equal to what? Sum of the two interiors. They are here theta 2 plus gamma or gamma plus theta 2. So here I am writing beta equal to theta 2 plus gamma. From this, what we are able to write? Theta 2 is equals to beta minus gamma. Here I transposed gamma on opposite side. So plus will become minus. So that's why it is written as beta minus gamma. Sir, why you found only theta 1 and theta 2? Why not alpha, beta, gamma, sir? Anybody? Anybody? Why we need only theta 1 and theta 2? Why not alpha, beta, gamma? Why don't we choose them? Because here theta 1 and theta 2 are incidence angle and refracted angles. Incident angle and refracted angles at point A. Clear? Why I am finding theta 1 and theta 2? It is because angle of incidence and angle of refraction, alpha, beta, gamma are angles, but they are made by certain light rays with the principal axis, right? Not angle of incidence, not angle of refraction. That's why I'm not touching them. If I required, I can find out them later, right? So this is, then here I got theta 1 equal to, and I got theta 2 is equals to. So here, can you establish the relation between angle of incidence and angle of refraction? What the relation is there? According to your 9th class, one formula is there, one law, that which establish the relation between angle of incidence and angle of refraction. Which law? Can anybody name that law? That is
Snell's law.
Very good, Snell's law. So what is Snell's law here actually? What is Snell's law actually? That is here n1 sin A equal to n2 sin R. Here I is written as theta 1 and R is written as theta 2 because respective to our diagram, I is equals to theta 1 and R is equals to theta 2. Clear? That's why I'm written Snell's law is n1 sin theta 1 is equal to n2 sin theta 2. Right? Then here substitute theta 1 and theta 2 values in Snell's law, n1 sin theta 1 equal to n2 sin theta 2. So what we can write? n1 sin alpha plus beta is equals to n2 sin beta minus gamma. So theta 1 and theta 2 values substituted here. Theta 1 equal to alpha plus beta. Theta 1 equal to alpha plus beta. And theta 2 is equals to beta minus gamma. So here they are replaced here. Theta 1 and theta 2 in the formula. I replaced it. Then what I'm doing here, simply approximating. Why here? Just I'll note down this as equation 1. Do you know alpha plus beta, alpha and beta angles, gamma angles? We don't know. So I'm unable to find out them because I'm going to generalize this one, right? So I don't want to find out. If I find and substitute, it will be applicable only for this situation, right? So I want to use this rule for any situation, for any image formation. That's why I'm not going to find out alpha, beta, gamma directly by measuring. So what I'm doing here, simply I'm trying to find out angle alpha. But I'm assuming that alpha is very, very small. If that angle is considered very small, what happens in your diagram? Just I will show you here. If angle is considered very smaller, look at here this. It becomes very close to the principal axis or not? Speak out. If I take that angle very smaller, how that ray will be observed here? It is very close or not? Just speak out. Yes, it is very close. And how it look like? Parallel to the principal axis or not? It is very, very closer. So it appears parallel to the principal axis. It appears parallel to the principal axis, right? So if a ray parallel to the principal axis and very close to the principal axis, two conditions are there. One is parallel to the principal axis and very close to the principal axis. That type of rays are called here paraxial rays. What their rays are called as paraxial rays. What are paraxial rays? Simple. They are very close to the principal axis and they are parallel to the principal axis. That rays are called as paraxial rays. Then here, what we'll do? We will not consider that angle alpha is very, very smaller, right? So we can consider this point very, very near to the principal axis, right? Very, very near to the principal axis. So the A brought very close to the principal axis. So here, what about this N? It moves towards the pole. Maybe it coincides with the pole also, very, very near to that. So they may coincide each other, right? So this we can approximate. This approximation is called as paraxial approximation. Paraxial approximation. So we know what is paraxial rays, what are paraxial rays, and what is paraxial approximation, right? So here paraxial rays and paraxial approximation, you need to learn that definitions are given in the page number 61. Clear? Paraxial rays and paraxial approximation. If there is any confusion, ask me immediately. Paraxial rays means parallel to the principal axis and very close. That rays are called paraxial rays. If very close, we can consider they are along with the principal axis only. That approximation is called paraxial approximation. So there are no points shown as A and N. So that approximation only called as paraxial approximation. So here what we can take, according to paraxial approximation, then sin alpha plus beta will be written as alpha plus gamma. This is only approximation. We are approximating that value to the alpha plus beta, right? Then beta minus gamma is also small. So sin of beta minus gamma will be written as beta minus gamma. So let us drop these values in the equation 1, right? Substitute these values in the equation 1. So what I can write here, n1 sin alpha plus beta will be written as alpha plus beta equal to n2 into sin beta minus gamma will be written as beta minus gamma. So this I got one more equation, and expanding n1 into alpha plus n1 into beta is equal to n2 into b minus n2 into gamma. Expanded, right? Solved. So I got one more formation for the equation 1. So that I am considering as equation 2 now. Up to here is very clear, or any confusion? Because we have few more steps in derivation. Remaining, no one responding. Okay, 4 responses. Okay, so let us see here. I got equation 2 here. Let us go for remaining steps. Here, finding alpha, beta, gamma values. How to find out? What are alpha, beta, gamma? Alpha is the angle made by the incident light ray with the principal axis. Beta is the angle made by the normal with principal axis. Gamma is the angle made by the refracted light ray with the principal axis, right? So that we have to find out. So for finding alpha, beta, gamma, I am depending on the right angular triangle to take tan theta. So I'm defining what is actually tan theta using right angle triangle here. So tan theta, according to your trigonometry, we have one formula, that is opposite side by adjacent side. Do you know this formula from your trigonometry? How many of you know this formula? Tejaswini, Medashri, okay, you got it. Right? So tan theta equal to opposite side by adjacent side. So this will be applicable only for the right angular triangle. So I have shown right angular triangle. If this triangle is ABC, certain triangle with right angle at B, I am assuming the angle size followed. So theta is at point vertex A and right angle at B, and another angle will be at C. So I'm not depending on the angle. I want to find out tan theta value by using this triangle. So tan theta equal to opposite side to the angle. Here your angle is at this place, right? So opposite to this one is this side, and adjacent side is this one. So opposite by adjacent. So what we can write? Tan theta is equals to opposite side is BC and adjacent side is AB. Is it clear how to take theta value from the right angle triangle using trigonometric ratio tan theta? Yes. So here I am finding alpha, beta, gamma using this knowledge, right? Using this knowledge, I'll try to find out alpha value and beta value and gamma value. So tan alpha equal to what we can write? Which triangle I have to consider? It is especially right angle triangle having the alpha as one of the angle. So which triangle help me to find out tan alpha? Anybody?
Triangle AON.
Very good. Triangle AON, right? So this meeting time completed. Immediately join everyone.